Okay, wait.
Maybe I should sit
Excuse me, Jenny. Yeah.
Alright. So, my presentation is on SAT scores over time, or versus time. So my variables, as you might imagine, are time and SAT score, with my explanatory variable being time and my response variable being your critical reading or math SAT score. So here's my graph of my data. As you can see, it's fairly linear, except for these 2 points at the end. And pay attention to those because a lot of my analysis is oriented around them. The regression for this particular set of data was 0.68. This means it has a moderate positive correlation. Over time, people's scores generally improve. But it might have been stronger if we didn't have those two outliers at the very end. The equation for this set of data is y equals 0.386x minus 1,750. This means at e equals 0, as funny as it sounds, the average score was negative 1,754, which of course makes no sense, but it is useful as a y-intercept. And every year, the scores will improve by 1.38. Using this equation, we can project into the future, and I did projections for 2015 this year, next year rather, 2020, and 2025. And as you can see here, I have a table talking about what the scores will be. So in 2015, people will have an average of 1,038. 2020, an average of 1,045, and 2025, an average of 1,052. Now, residuals. The residuals are how much error you have in your linear equation. And normally you want them to be very random. And while mine is kind of random, it isn't quite. You can see here we have a couple low points, and then we are generally above, and then we have a couple more low points. Now, normally this means that a linear model is not the correct model for that particular set of data. In my case, I don't think that's right. That's fine. So the two outliers at the very end break the positive correlation. It was going up and up and up, and then you have these two outliers at the very end that bring it down. Which means your entire regression line is also going to be shifted downward. As a result, it will underestimate the data, except for at the very beginning, at the very end, which is accurate. And while that's very complex and hard to get your head around, this might help a little bit. You can see at the very beginning and at the very end, you've got these weird outliers, right? And since these are pulling the entire line down, that means for the middle portion of the data, it is going to be underestimating the results. Aside from that, that's about it, and thank you for sitting through it.